Hey folks, and welcome back to Adam's Workshop. So today on the bench, I wanted to kind of do a twofold. One, I wanted to very briefly introduce this new kit that I have. I did pay for this myself, and I just think it's a really neat kit. I wanted to share it with you guys. It's the ELEGOO, and it's called the Most Complete Starter Kit with the Mega 2560 project. And inside you have plenty of different sensors, wires, remotes, boards, just all kinds of different stuff. I'm not going to go into it all. This isn't going to be a video. This isn't going to be a video all about the kit. It's just, I just wanted to briefly introduce it. And just let you know, if you've been thinking about getting it, it's a runoff, I guess, of the Arduino. Arduino is an open source, so others can also make it, and the ELEGOO was less expensive, so I purchased it off of Amazon, and I've been playing with some of the projects, and so I wanted to just mention the kit, and I thought I'd show you one of the projects. This is lesson 4, and it's a RGB LED, which is a red, green, and blue light emitting diode. That's what an LED is. And let me see, if I turn the light off here, you'll see the end result. It's basically an LED, and it's changing colors. There's 3 bulbs, 3 LEDs in one bulb. There's obviously a red, a green, and a blue, hence the RGB. There's 3 legs running off of it, 1 leg for each bulb, and then an additional leg, which is known as the cathode. This is a common cathode LED. You also have common anodes. This is a common cathode where the longer leg running off of it, let me turn these lights back on, the longer leg running off of it goes to ground. See if I can show you this. I know it kind of looks like a big clutter of wires here. It's a really simple setup. Most of these wires are my oscilloscope probes. So right here, going to the bulb, you have right in front of it on the longer leg, the cathode, you have a black wire going to ground on the board. And then in front of each leg for each color, you have a 220 ohm resistor, because with LEDs you have to run resistors, otherwise you'll overload and burn out the bulbs. So you have the 220 ohm resistors, and in front of that you have a wire connecting those onto the board, onto, let me see if I can show you here without moving all this. Basically, y'all are going to have to take my word for it. On the side of the board here, we're plugged into the Pulse Width Modulated drivers. I guess they'd be called drivers. If they're not, and somebody knows they're called something else, go ahead and correct me on that in the comments. And so basically, once you wire everything up, oh, and the rest of these wires here, all these black wires, these are just grounds for my oscilloscope leads. And I'm connected my ground leads obviously to the ground. I have one ground going from the board here over to another ground on the 2560, the Mega 2560, and the main leads connected to each of the leads going to each of the colors. And for each wire, green, red, and blue, that corresponds with the color, which will also correspond on the scope for the leads. The blue is the blue light, the pink is the red, close I could do, and the green is the green light. We'll get to that in a second. So anyway, I was sitting here and I was thinking, man, you know, how is it controlled? How are we changing the colors? And being that there's 3 colors in there, but when the bulb glows, it looks like it makes other colors. And the way it's doing that is we're turning up. We're putting more power to one color, less power to another color, and turning one color off all at the same time. And we're doing that with pulse width modulation to control the power. And that's how we're controlling the brightness of each of the LEDs, and that's how we control the power. And I was thinking to myself, you know, what would that look like if you didn't have an oscilloscope? And so I grabbed my multimeter, and I just wanted to see. Let's see here. I just wanted to see what you would see without a multimeter. And so let's find out. We're going to go the black to the cathode. And we'll go the other one to the green. And watch the numbers change. You'll see when it turns off. You'll see when it's at its highest peak. That's when it's the brightest. And then there it turns off real quick. And then it gets, you know, its most power for a certain amount of time, and it just keeps recycling through. And it does that, the computer does that for each color, for whatever it was coded for. And on this kit, when you're putting it together, it shows you the code. You have to download it and everything. Everything's there. You download it all one time, and then you have it all in libraries. But anyway, I thought, you know, that's so boring, and I wanted people that don't have an oscilloscope to see, you know, what they're missing. I'm going to put you on the screen here, on the larger screen. I just wanted people to see what they're missing. I put the numbers for the green bulb on the bottom, also the frequency up on the top left corner. Like I said, this can be a real quick video. I'm already basically done. I just wanted people that don't have an oscilloscope, if you're thinking about getting one, if you're wondering what you're missing, guys, it'll open up a whole world for you. I'm telling you, I had no idea until I got my first one. You're really missing out if you're looking at electricity through a multimeter versus a scope. You know, our eyes see colors and pictures so much better than numbers. It's just so much easier to see what's going on. So you can see right here, well, it's going to switch. Like this blue line, it's turned off. That's ground. Now it's getting power, and it's going up to 5 volts, and it's turning it on for so long. And when it has 5 volts, that's when it's at its brightest. But when it does that with one color, it turns off another color. And it just keeps rotating that depending on how it was coded to do so. And that's how we're seeing the different colors, because our eyes see in the red, green, blue spectrum. And so we're tricking our brain using the red, green spectrum to make it appear like there's different colors, because there's not different colors here. The only color we're seeing, or the only colors that's actually really here, is a red, a blue, and a green. But you see pink, you see violets, you see all different colors. And I just think that's really neat. I just wanted to share that with you guys. Like I said, also, if you've been thinking about getting a ELEGOO or an Arduino, or if they have any other names, and if you like tinkering with electronics, go for it, guys. You're gonna love it. You're gonna have fun. No, I'm not sponsored by anybody. I wish I was. No, I'm not being paid by anybody. And I bought this ELEGOO set with my own money. So that's it, guys. Just wanted y'all to see. I just think that's really neat. I just wanted to share it with you guys. If you don't have a scope, an oscilloscope, get one. You will not be disappointed. You'll love it. You'll have all kinds of fun with it. You'll have fun doing all kinds of things. Like I said, it's like putting glasses on that allows you to see a whole nother world, and you'll really start to make sense out of all the stuff you're reading about on paper. Alright, that's it guys. That's all I got. I just wanted to mention it. Just wanted to mention that ELEGOO Mega 2560 kit. It's a neat kit, has a lot of fun projects. Next I'm going to get, they have like a 37-in-1 sensor kit. I'm going to get that next. What you can do with all this stuff is, I mean, as far as your imagination can go, unlimited things you can do with all these sensors and the coding and the boards and everything combined together. And then you get to see it all on the oscilloscope when you're done. It's like you actually get to see the coding taking place in front of your eyes. You know. Anyway, guys, that's exciting to me. Just wanted to share it with you guys. And thanks again for stopping by the channel. This is Adam signing off from Adam's Workshop. Thanks for stopping by.